Alright guys, this is a video about intervals, domain range, and end behavior. So on top of the screen it says intervals of a function are positive, will be above the x-axis, and negative when below the x-axis. So this section of the graph right up here will be the positive section of the graph. So that's where the positive interval is. It's that portion of the graph. Below the x-axis will be the negative part. Now for a lot of people it's very hard for people to write their interval using set builder notation when they're only looking at the graph. So what I'm going to do is I'm going to make a table that's going to help us represent this line. So this point right here that I'm marking in red, 2, 0, is what I like to call our neutral point. It's not part of the positive interval, it's not part of the negative interval because it's on the x-axis. So I'm going to go ahead and mark some points on this graph. I'm going to use green for that. And I'm going to put those in my table. So I have 0, -4, 1, -2, and then I have 3, 2, and 4, 4. So looking at our table, we can see the y values right here are negative. Hence, they're going to be part of the negative interval. The y values down here, where it's 2 and 4, are positive, so they're going to be part of the positive interval. Our neutral point is what we're going to use to help us write the intervals in set builder notation. So I'm going to go ahead and set up my bracket, x such that, now I can see for the positive interval, those are where the y's are positive. So I'm going to write it in terms of x. I'm always writing my intervals in terms of x. So any number that is greater than 2 is going to give us a y value that's positive. So therefore, x has to be greater than 2 because that's where the positive interval is occurring, because the y values are positive. But we are talking about it in terms of x. Hence, x is greater than 2. So any x value greater than this red point, this section of the graph, that's the positive interval. That's what we're describing here in our notation. We'll do the same thing with the negative interval. So the y values in the table where they're negative are up here, -4, -2. But if we look at it in terms of the x's, any x value that is less than 2 is part of our negative interval because that makes the y's negative. That's the bottom section of the graph. So we can write our set builder notation to describe our negative interval as x such that x is less than 2, talking about this section of the graph, which is happening before 2 on our x-axis. Let's look at another example that we did in class. So we have a parabola in blue. This time we have 2 neutral points right here in the number 1 and the number 4. You'll see if we look at those 2 points, it kind of breaks the graph up into 3 different sections. This section here, down here, and here. And once again, if we want the positive interval, it's the sections that are above the x-axis. Once again, I'm going to use a table to help understand what's going on here. So making a little table for this graph, say I start here at -1, I think there's a point up here that's probably around 7. So -1, 7, 0, 4, 1, 0, 2, -2, 3, -2, 4, 0, 5, 4, and we'll say 6 is probably up here around 7. We're going to go ahead and I'm going to make a little box around our 2 x-intercepts, which I like to call the kind of the neutral points. They're not in the positive interval and they're not in the negative interval. So looking at our table, we can see that the y values that are positive are right up here and down at the very bottom of our table. That's this section on the graph and this section of the graph. These are the positive part. Positive. The part of the table has negative numbers is right here, which is referring to this bottom hump down here of our graph. So if I'm going to try to describe the positive interval, or intervals in this case, it's going to look something like this. X such that. Now once again, I'm writing this in terms of x. So the x values, where the y's are positive, would be right here. 0, -1. If we continued this table, it'd be -2 and -3. It's all the x values that are less than the number 1. So I can say x is less than 1 to describe this section of the graph. Or down here at the bottom of the table where my y's are positive again, those are using the x values that are greater than 4, referring to this section of the graph. So any x value that is greater than 4 is also a positive interval. It's the positive part of our graph. And those are the positive is referring to being above the x-axis that is right here. For our negative interval, that's this bottom section. That's this part of the graph where we have -2 and -2 as our y values. Once again, we're talking about it in terms of x. So all the numbers between 1 and 4 here in the x column make up this negative interval. The way I write that with our set builder notation is 1 is less than x, which is less than 4. This time, since the interval is between two values, between 1 and 4, we can write it like you see here in green on the bottom. It's basically trying to say it's all the x values between 1 and 4. Okay, moving on from positive intervals and negative intervals to our next thing, intervals that are increasing and intervals that are decreasing. So what we care about when dealing with this is understanding that an increasing interval has its x value increase and the y value increase. Decreasing intervals of our graph will be increasing and then decreasing. So looking at our graph, I'm looking for when the graph changes direction. So currently I have this graph, it's going this way as I read from left side to the right side like I read words. So this line's going this way, and then all of a sudden it changes direction and then it heads this way. That point where it changes direction is right here. It's called our vertex. That point is 2, 1. I'm going to make myself a little table over here. 2, 1. I'm going to go ahead and complete this table a little bit. At x is 1, the y is 2. And when x is 0, the y is 3. When x is 3, the y is 2. And when x is 4, the y is 3. So now I'm basically looking in the table, where does the y increase and where does the y decrease? So if I'm starting at the top of my table, I have 3, 2, then 1, and then it changes increasing to 1, 2, then 3. So this point right here, that vertex point, the point where the graph changes direction, will be the values we want to use to write our notation. Specifically, we want to use the number 2. We write our intervals in terms of x. So we can see in the y column 3, 2, 1. This is decreasing. I know that is that decreasing part of my graph because I can see it in the y's. But to describe it in terms of set builder notation, I'm going to say x such that x is less than 2. And that's because all the x values that make the y values, where those y values are decreasing, are all the x values before 2, all the ones that are less than 2. Now, if we go ahead and we look at more of the table, we can see once we get to that vertex point, the point where the graph changes direction, it goes 1, 2, then 3. It's now increasing. So we have an increasing interval. Once again, we'll describe it in terms of x. So I'm talking about all the numbers that are greater than 2. So I make my bracket x such that x is greater than 2. And that's describing my positive interval. Sorry, my increasing interval. So looking at one more, for the increasing and decreasing, we're going to look at a parabola like we did in class. So once again, I'm going to make myself a table, and I care about where is that point where the graph changes direction. I'm just going to make a little table of my graph. I'm going to start off with this 2 here, 2 comma negative 1, 3 comma 2, 4 comma 3, 5 comma 2, and 6 comma negative 1. And so I'm looking for the point where it changes from increasing to decreasing or decreasing to increasing, where the graph changes directions. It's changing directions in the y right here. You can see negative 1, 2, 3, that was increasing, and now it switches 3, 2, 1, and now it's decreasing. So I know this part is increasing and this part is decreasing. That point is located right here on the graph. So the left side of the graph, all the numbers that are less than 4 is where the graph is increasing. So I'm going to write my increasing interval in set builder notation, x such that x is less than 4. So all these values that are less than 4 here in the x is where the graph is increasing. Doing the same thing over here. For the decreasing interval, where we saw in the y column, we went 3, 2, negative 1, all the values that are greater than 4 is where the y values are decreasing. So any value greater than 4 is where the graph decreases. So x has to be greater than 4. I'm going to do one more about this. Actually, no, let's move on. Domain and range. So this is a little review of Algebra 1. Domain is the x values that create our graph here. So looking at this graph, we can see that at negative 4, there's nothing for the blue line. There's no blue line here at negative 4 if we look up or down. When we get to negative 3, we see a point on that blue line. At negative 2, we see a point on the line. Negative 1, a point on the line. 0, point on the line, and so on and so on and so on. As we continue to increase the x's, we can see there's points making this line. Therefore, our domain is x is greater than or equal to negative 3. Now we're putting the equal to because there's actually a point at negative 3 for the x. Our range is doing the same thing, but we're looking at the y-axis. So range is referring to the y values that create the graph. If we look down here at 0, there's no blue line in either direction of 0. But if we look at 1, we see there's that point. So 1 is the very first number that creates a point on our blue graph. 2 creates a point on our blue graph. 3 creates a point on our blue graph. 4 makes a point on our blue graph. So any y value that is greater than or equal to 1 creates a point on that blue graph. Over here on the right, we have an absolute value graph, and we'll look at its domain. So our domain, once again, are all those x values that make this graph. So we can start here at 3, we have a point on the graph. We can see over here at 7, we've got a point on the graph. At 8, a point on the graph. This little blue arrow is letting you know that this graph is going on forever. So it's going to use x values like 9, 10, 20, 100, a billion. It's going to use all the positive x values. As we look to the left of the graph, when we're at 0, we have a point on the graph. At -3, we have a point at the graph. At -2, point at the graph. As we continue to go into the negatives, -10, -20, -a billion, this graph is going on forever, so it's using all of our x values, and we call that all real numbers. And this is how you write that notation, x, such that x is an element of all real numbers. Then range. So if we look for the range, once again, the y values that create this graph. So we can see here at -1, there is nothing touching the blue line. Therefore, -1 is not part of the range. But if we go to -2, we can see there's a point on the blue line. -3, there are 2 points on the blue line when y is -3. At -4, we have 2 points on the line. Therefore, the y values that create this graph are all the y values that are -2 and below. So we can say that the range is y such that y is less than or equal to -2. In behavior, this is where we look at the behavior of the graph on the left side of it and the right side of it. So we're going to start off with left side. We're going to talk about it in terms of x and y. As we go to the left of this graph, as we move our x's into the negatives, -1, -2, -3, -4, -5, -6, -7, as we continue on forever, as x approaches negative infinity, the question becomes, which way does the y go? Well, we can see this graph is pointing up, so it's heading towards all the positive y values going on forever. Therefore, y must approach positive infinity. So if your graph is pointing up on the left side, you should have a positive infinity for our end behavior of the left side of the graph. Now, if we look at the right side of the graph, as we continue extending this graph, we'll see that we have x values like 5, 6, 7, 8, 9, 10, 11, 12, going on forever. So as x approaches positive infinity, the question becomes, where's the y's going? Well, once again, this graph has the graph pointing up. It's heading towards all the positive y values. So y heads towards positive infinity. If you look at the one on the right, this one's just a little different, but once again, we're still going to go ahead and look at left side and then right side. So left side, once again, as we continue looking to the left of the x, we are using -8, -9, -10, -20, -a billion. It goes on forever. So as x heads towards negative infinity, the question becomes, where does the y head towards? Well, this is that exponential graph we talked about in class, where there's an asymptote right here. It's an invisible line that this green line will never cross, but it heads towards it. And this purple line is on the x-axis, which is where the y value is 0. So y is approaching the number 0, but it never goes past it because it can't get past that purple line. Looking at the right side of the graph, as x approaches positive infinity. So as these x values on our graph get larger, they're heading towards positive infinity. But the question is, where's the y going? Well, if we look at our green graph, it's pointing up. So it has to head towards positive infinity. If your graph ever points down, then the y heads to negative infinity. I hope this little video has helped you where you can go ahead and refresh your memory as you do your homework. You probably won't see too many of these videos in the future. I just know this is a very hard topic and we didn't have as much time as I wish we had to do in class.